What's way out there? What are things that we haven't seen really come to fruition yet that would bring this demand way down and start to get us towards balance? Well, there's wireless networks, ultra-wideband. That one's out there ways. How about power amplifiers for MEMS? MEMS, RF. Hey, a lot of work there. Some of that's actually starting to show up. Maybe not so far out. And then how about reflective bistable display technologies? If you can get one of these, they do everything the aggregate before gave you. One does 20%, whereas the aggregate gave you 20% before. The aggregate of these, 75%. Now we're really starting to push down on this demand. We're really starting to reduce the energy consumption of these components, and we're really starting to get close to some balance. But we're never quite there. And as you look at these items, and as I leave the room later today, you'll say, yeah, those are some great things Jim talked about. But God, they're really far out there. Actually, as the bottom line suggests, objects in the mirror are closer than they appear. Some of these technologies, like the RF, the MEMS for RF switches, and some of the bistable technologies, they're actually in the market today. My point here is, to get the real gains, you're going to need disruptive technologies. And when you see them, they may not be the holy grail that you are working on right now today, but you need to reach back and pull them into the market sooner rather than later. Don't wait, be proactive. Because as I get to the next slide, we've been talking about reducing demand. Where's the supply? Supply is a big question mark. Talking about reducing demand, right? Near term, longer term. What can you do on that supply? There's fuel cells, there's wireless charging, there's solar charging, mechanical charging. These are not trivial. They require fundamental technology breakthroughs, and more importantly, they require behavioral changes. So let me give you a couple examples. Solar charging. They talk about putting that on your handset itself. I don't know about you guys, but there's not a lot of light in my pocket. Right? And I don't want to carry a brick around to charge it. How about kinetics? You really want to wire up and walk 6 miles so you can talk 5 minutes on the phone?
Great for teenagers.
Yeah, good for teenagers, yep. Good point. I probably won't get my son to wear it, but good point. It'll probably reduce the number of games he plays. Fuel cells, there's adaptive changes there as well. Who's going to maintain it? Wireless charging, how efficient will it be? These are all great. And if we could get one of these, you've now solved the supply issue. And if supply ever becomes ubiquitous, this whole problem with supply and demand, it disappears. But this is a big question mark. No one really knows when these things can come through. And so what you really have is just a demand side that you can work on. In the demand side, like I talked about, the stuff that's near term, it's just a 20% gain. Hard work. We really need those disruptive technologies to come through. So I'll give you another example. If we could get one of those disruptives to come through and get into your designs, what does it really do for you? Because a lot of us think, just get the power down, get the power down. I think it needs to be a broader picture on what those benefits really do throughout the entire value chain. So if you look at display technologies and you look at disruptive displays that are bistable and reflective, and there are several of them out there, they're on this left-hand column. They're extremely low power. They're about 1 milliwatt in a static state versus what you see on the far right-hand column, which is an LCD, about 240 milliwatts. Now, the reason is they're reflective technologies. They use the ambient light around us to create the image, whereas an LCD is a light valve, and it needs a backlight. And the backlight's really the big contributor of that energy consumption. Now, if you could bring one of these into your designs, now some of you are already thinking, wow, 1 milliwatt versus 240, that does a lot for me. It does quite a bit. And in fact, think about it just beyond your design. So whether you're designing components or systems, think about everyone through this food chain on how they benefit from a lower energy design. Start right off with that handset designer. Remember when I talked to you before about bigger battery, how it impacts the handset? You're going to make this guy's life much better. Now he can use a smaller battery. He doesn't have to use that bigger one or that wider one, because when he does, it creates that big black area around the display. Now he's got a big bezel. How does he solve that? He puts in a bigger display. What did he do? Added cost, and up went the power. Now he doesn't have to do that. He can use a smaller display and a smaller battery. How about the manufacturer? Price difference between an 1100 milliamp hour battery and a 740? $1.50? Million units a month? It starts to add up. How about the handset product managers? Those guys are always desperate, looking for power budgets to put in more features. Boy, I'd really like to put that GPS in this handset. But, with the GPS and the web surfing and a few other things, I'm not going to have enough power. It's not going to give me enough time in between charges. This gives you more flexibility. You can put in more features. How about that carrier? How many of you have done a product design where you've actually thought about what the carrier thinks? You can show, if you design with a technology like we talked about that saves 30%, you can show where the carrier improves its ARPU, average revenue per user. That's how they make their money. That's how they get the money out of your pocket and out of my pocket. It's ARPU. How do they get it? How do they improve it? They have a thing called available revenue time, ART, which is the amount of time that a handset is fully functioning in between charges. If the handset doesn't make it, whether that be a 12-hour period, a 6-hour period, or what have you, or a 2-day period, the phone is not available to download another ringtone, another MP3 song, another data packet, more web surfing. If you can reduce the power by 30% in your design, you literally have a way to show the carrier how they can increase their ARPU, and it's not $2, it's not $3. Many of their models are more than that. And then there's the user. Now, we all design for the user, but you think about this whole power thing. How does it help them too much other than we meet their expectations, they make it through the day? How many chargers do we all have at our house? Right? Who knows how many chargers you have for stuff that you don't own anymore? Right? I threw a box out the other day. It was like this. It's huge. Probably paid $300 for all those chargers. I have 3 phone chargers. 2 of them I can't find, but I know I have 3. And I have 3 home chargers, AC. I have no idea where they are. You get the idea? Those add up. Many of my friends carry extra batteries. I can't even keep those in my pocket. But it's more valuable than just buying extra chargers or batteries. The user itself, and you've probably never seen data like this. When you do your design, this is how important it is to the user to get more energy out of that handset. So you ask these, this is a survey that Spears Research did, and it said, how valuable would you find a longer battery life in your handset? Would it be valuable or not? It's 55% said highly, 20% said valuable. I'm going to say 75%. Well, that's an obvious statement, right? Didn't even have to ask that question. But the one I really like is, would you pay more? Would you pay $10 more? Overwhelming number said they would. So if you think about that whole value chain that I just went through, right? You're saving money at the manufacturer. You're making the designer's life easier. You're raising that ARPU at the carrier. You're saving the user money. And oh, by the way, he'll pay more to save that money. Doesn't that make you think that your designs should ripple through and you should get more for your designs if you can hack 30% off by bringing new technologies in sooner rather than later? Absolutely.